This video is on rate in and rate out problems. So the problem says, a company manufactures soft drinks according to a secret formula and special mixing procedures. After mixing, the beverage is moved into a storage container for bottling. The rate at which the beverage flows into the storage container is modeled by the function R, where R of T equals this whole equation, gallons per minute, T is measured in minutes, and 0 is less than or equal to T is less than or equal to 60. Bottles are filled using the beverage in the storage container at a rate modeled by B of T, again in gallons per minute, for 0 is less than or equal to T is less than or equal to 60. There are 2,000 gallons of beverage in the storage container at time T. So the first thing we need to do is understand what's been given to us. So we're given the fact that there's a storage container and it's being filled up with a beverage. So I'm just going to draw some beverage. And R of T is the rate at which the beverage flows into the storage container. So we would call this the rate in. Oops. Okay, so I'm going to draw R of T, that's our rate in, and it's in gallons per minute. All right, then we have B of T, and it says bottles are filled using the beverage in the storage container at this rate. So bottles being filled with this beverage means that the beverage is coming out of the storage container. So it's going out and, being bottled. We'll just draw a bottle. That's a terrible bottle, but we'll just imagine. All right, so this is the rate at which the beverage is flowing out, again in gallons per minute. Then we're given one other piece of information. It says there are 2,000 gallons at time T equals 0. So this is our initial quantity. And that may help us to solve problems later on. So we can just say like initially, I'm going to call this XO, it's 2,000 gallons. Okay, so question A says, is the amount of beverage in the storage container increasing or decreasing at T equals 10 minutes? And then give a reason. So we have to decide yes or no, and then actually explain it somehow. So at T equals 10 means we don't really need to think about the initial amount right now. What we need to think about is whether the beverage in the container is increasing or decreasing. So is there more or less as time goes on when we're looking at T equals 10? So in order to figure out if it's going up or down, we need to compare the rate in with the rate out. So our rate in and our rate out, how do those two things compare at T equals 10? So really what we need to do is figure out what R of 10 and B of 10 are, or at least compare them. So I'm going to plug these equations into my calculator. So in Y1, I'm going to put R of T, so I have that. And in Y2, I'm going to put B of T. So I can use these over and over again as I solve these problems. So take a minute to plug that into your calculator. And then once you've done that, we can go to alpha. So on the home screen, go to alpha and then trace. And the options pop up with the different Y1, Y2, Y3, etc. And we can press Y1. So on the screen you've got Y1 and then you can type parentheses 10 close parentheses. And you will get about 141.244. And again, that's gallons per minute because this is a rate at which beverage is flowing into the container. Now I can do the same thing, but with Y2. And so Y2 shows up on the screen, put parentheses 10, and then this is going to be about 154.919. It's 9 gallons per minute. Okay, so 154 is bigger than 141. This was the rate in, and this was the rate out. So the rate out is faster than the rate in. That means that you are going to be losing beverage over time, that the amount of beverage in the storage container is actually decreasing. Okay, so let's think about how we would word this. So this is question A. You might say, since, let's see, B of 10, because remember this y2 was our B of t, and this was our r of t in y1. Since B of 10 is greater than R of 10, the amount of beverage in the storage container, so we're giving the context and explaining what it means, in the storage container is decreasing at t equals 10. So that's one way to explain your answer. We could have also, there's not a whole lot of room here, but we could have said that R of 10 minus B of 10, so the rate in minus the rate out, equals approximately 13.675. So if you had subtracted those, and negative 13.675, and that's less than 0. So if we said R of 10 minus B of 10 is approximately negative 13.675, which is less than 0, we could say, so the amount of beverage in the storage container is decreasing at t equals 10. So essentially we jump in here at this part of the explanation, because the rate in is less than the rate out. Okay, so how is this part of the problem scored? You would essentially get 1 point for this statement here, that R of 10 minus B of 10 is less than 0, or this part, where we establish that the rate out is greater than the rate in. So that gets you 1 point. The second point in the problem is stating what it means, essentially, that the amount of beverage in the container is decreasing. So for that part of the answer, we get another point. So part A is worth 2 points. Okay, let's take a look at part B. How many gallons of beverage flow into the storage container during the 30-minute time interval from 0 to 30? So how many gallons? So we're not talking about a rate this time. We're talking about overall how many gallons of beverage go into the container. Okay, so let's clear the screen really quickly so we can tackle B. Okay, since we're talking about beverage flowing into the container, we are going to be using R somehow. And we know R of t is in gallons per minute, but we want to go to just gallons. So imagine that we're graphing R of t, and it looks something like this. So we're going to say that this is R of t in gallons per minute. And we want to go just to gallons. Well, let's think about what's on our x-axis. This would be time in minutes. If we take something that's in gallons per minute, so this y value up here, let's say it's like 10 gallons per minute, and we multiply it, so this is our gallons per minute, and we multiply it by time, by minutes, we get an area under the curve, but maybe more importantly, we go from gallons per minute times minutes, which gives us just gallons. So we go from a rate to just a quantity by multiplying by time, or by finding the area under the curve here. So if we're finding an area under the curve, that means that we are going to need an integral. So let's clear a little space here. If we're looking for the amount of beverage, the gallons, from 0 to 30, that means we're looking for an integral from 0 to 30 of R of t dt. And we don't need to integrate this by hand. We just literally plug this in the calculator. So you would use math and number 9. So the math button, number 9, that's the f int. And you'd put in this integral 0 to 30 and y1 because we put r of t and y1, dx on the calculator. And when you plug that in, you get approximately 3,708.725, and then this should be gallons. So after about 30 minutes, there are 3,708.725 gallons that have flowed into. So it's not asking how many are there overall, it's asked how many are flowing in. And so the integral gives us the amount of change, the amount that has flowed in during that time period. So how is this scored? Well, you actually get 1 point just for setting up this integral correctly from 0 to 30 of r of t, and you get 1 point for getting the number correct. Again, you should not attempt to integrate this by hand. You should use your calculator. This is a calculator problem. Okay, so now let's look at C. C asks how many gallons of beverage are in the container at t equals 40. So not how many have flowed in, how many are there total. So gallons are in the storage container at t equals 40, and I'm going to put that this is asking for a total. Since we're asking for the total or overall, we will have to consider the initial amount that was there. So let's clear our screen really quickly so we can work on C. Okay, so in order to do C, we need to think about, in order to find the total quantity, the total number of gallons, we need to think about our initial number of gallons in the storage container and the quantity that has flowed in and the quantity that has flowed out. So we're going to be adding an integral with it's the integral of our rate of change, essentially, the net change. We want this integral to give us the net change. So it needs to consider both what's flowing in and what's flowing out. So the way we'd actually need to do this is we could say the total equals 2,000, because that's how much we started with, 2,000 gallons, plus the integral from 0 to 40 of r of t, so that's how much is flowing in, minus b of t, and that's the rate that it's flowing out. So this is flow in, flow out, but when we take the integral of it, it gives us the amount or the quantity that has flowed in and flowed out. So you can either do this as one big integral, so integrate these two rates being subtracted, or if you wanted, you could do them as separate integrals, 0 to 40 of r of t dt, the quantity that flows in, minus the quantity that flows out. Either way, you're going to get the same result. And again, don't do this by hand, use your calculator. So when you plug this in your calculator, you're going to get 105.391 gallons. So let's talk about how this is scored. You get 1 point just for remembering that you have to consider the initial condition when you're talking about the total or overall quantity. You get your next point by taking the integral of r of t minus b of t dt from 0 to 40. So knowing how to set up that integral to find the change from 0 to 40. And then the final point comes from getting the correct answer here of approximately 105.391 gallons. So let's just think for a second if that answer makes sense. We started with 2,000. We found in part A that the beverage is decreasing over time. So it makes sense that after 40 minutes, we'd go something lower than 2,000. Here it's pretty dramatic. It's 105.391 gallons. Okay, so that's part C. Let's take a look at part D. D asks us to find b prime of 50 and using correct units, explain the meaning of this value in the context of the problem. So let's first remember that b of t is measured in gallons per minute. if we take the derivative of that, it's finding the slope of that original graph. That means that you're taking this y value that's in gallons per minute and dividing by the run, or dividing by the x, which is measured in minutes. So we're dividing by minutes again. So this is actually in gallons per minute squared, right? Gallons per minute per minute. This matches up with particle motion. When we do particle motion, our, let's say, b of t here is equivalent sort of like to velocity. Velocity would be in miles per hour. And then b prime of t is like acceleration. So if this is miles per hour, per hour, acceleration is in miles per hour squared, right? So that's what we're thinking about. We're taking the derivative of a rate. Velocity is a rate. The flow out rate in this problem is what we're taking the derivative of. And we get something sort of like acceleration, where it's the rate of the rate of change of the rate. So, okay, so that's just thinking about units. Let's actually find b prime of 50 and think about what that means in the context of the problem. So again, you shouldn't do this by hand. You should use your calculator. And in order to find b prime of 50, what you're going to do is press the math button, and you're going to go to number 8. That's the n-deriv option. And it will ask you to put in variables and letters so that it looks like this. We're taking y2. y2 was our b of t. And then it'll look like x equals 50. So this is what you're plugging in your calculator. And when you do that, you should get approximately negative 5.164 gallons per minute squared. Okay, so you get 1 point just for answering that correctly, coming up with this number. The next point is really about interpreting what that means. And I'm going to erase some here so we've got room for that interpretation. So what the readers are really looking for here is for you to say something like this. At t equals 50, the rate at which bottles are being filled and this is just a reference to b of t, right? The rate at which the bottles are filled is b of t. Let me put this in red here. You don't have to actually put b of t in your explanation, but I want us to know that that's what we're talking about, right? The rate at which bottles are filled decreases. That rate is decreasing because, like, how do we know? It's because this is negative. So that rate is decreasing, and it's decreasing at a rate of 5.164 gallons per minute squared. So in your answer, they're looking for you to interpret. So here, we're interpreting the negative. It means that the rate is decreasing over time. And they want us to include units and to include the number here. So what we're really saying is that the rate of change of b of t, the rate of change of the rate at which bottles are filled, is negative, which means that it's decreasing at approximately 5.164 gallons per minute squared. And that's the final point in this problem, is this interpretation or explanation of b prime of 50. And that's it. Now on to the practice problems for more rate in, rate out problems.